So IPv4 header, this is a very important question from university point of view. So this is the format of IPv4 header. We will see each part. So first is your version. Version is a 4-bit field that indicates the IP version used. The most popularly used IP versions are version 4 IPv4 and version 6 IPv6. Only IPv4 uses the above header, so this field always contains the decimal value 4. So always you will have the decimal value 4 in this part. Next is the header length. So this is the header length. Header length is a 4-bit field that contains the length of the IP header. It helps in knowing from where the actual data begins. Minimum and maximum header length. The length of IP header always lies in the range of 20 bytes to 60 bytes. The initial 5 rows of the IP header are always used. So the minimum length of IP header is 4 into 5, that is 20 bytes. The size of the 6th row representing the options field vary. The size of the options field can go up to 40 bytes. So the maximum length will be 60 bytes. Concept of scaling factor. Header length is a 4-bit field. So the range of the decimal values that can be represented is 0, 15. But the range of the header length is 20, 60. So to represent the header length, we use the scaling factor of 4. Header length is equal to header length field value into 4 bytes. So if the header length contains decimal value 5 represented as 0101, then the header length is 5 into 4, that is 20 bytes. If the header length field contains decimal value 10, then header length will be 10 into 4, that is 40 bytes. If it is containing decimal value 15, then 15 into 4 is 60 bytes. So this is the way you will find the header length. Next is types of services. So types of service is a 8-bit field that is used for quality of service QoS. The datagram is marked for giving a certain treatment using this field. Next is total length. Total length is 16 bits that contains the total length of the datagram in bytes. Total length is equal to header length plus payload or data length. Minimum total length of datagram is 20 bytes. 20 bytes header plus 0 bytes data. Maximum total length of datagram is maximum value of 16-bit word equal to 65535 bits. Next is identification. Identification is a 16-bit field. It is used for identification of fragments of an original IP datagram. When an IP datagram is fragmented, each fragmented datagram is assigned the same identification number. This number is useful during the assembly of fragmented datagrams. It helps to identify to which IP datagram the fragmented datagram belongs to. Then you have the DF bit. DF bit stands for do not fragment bit. Its value may be 0 or 1. When the DF bit is set to 0, it guarantees the permission to the intermediate devices to fragment the datagram if required. When the DF bit is set to 1, it indicates the intermediate devices not to fragment the IP datagram at any cost. If network requires the datagram to be fragmented to travel further but settings does not allow its fragmentation, then it is discarded. An error message is sent to the sender saying that the datagram has been discarded due to its setting up. MF bit stands for more fragments bit. Its value may be 0 or 1. When the MF bit is set to 0, it indicates to the receiver that the current datagram is either the last fragment in the set or that it is the only fragment. When MF bit is set to 1, it indicates to the receiver that the current datagram is a fragment of some larger datagram. More fragments are following. MF bit is set to 1 on all fragments except the last one. So we saw MF bit, DF bit, then we have a fragment onset. Fragment offset. Fragment offset is a 13-bit field. It indicates the position of the fragmented datagram in the original unfragmented IP datagram. The first fragmented datagram has a fragment offset of 0. Fragment offset has a given fragmented datagram equal to number of data bytes ahead of it in the original unfragmented datagram. Concept of scaling factor. We use a scaling factor of 8 for the fragment offset. Fragment offset field value is equal to fragment offset divided by 8. Then time to live. Time to live is a 8-bit field. It indicates the maximum number of hops in a datagram that can reach to the destination. The main purpose of time to live is to prevent the IP datagrams from looping around forever in a routing loop. The value of time to live is decremented by 1 when the datagram takes a hop to an intermediate device having network layer up. Datagram takes a hop to the destination. If the value of time to live becomes 0 before reaching the destination, then datagram is discarded. Protocol is an 8-bit field. It tells the network layer at the destination host to which protocol the IP datagram belongs to. In other words, it tells the next level protocol to the network layer at the destination site. Protocol number of ICMP is 1, IGMP is 2, TCP is 6 and UDP is 17. Why protocol number is a part of the IP header? Consider an IP datagram is sent by the sender to the receiver. When the datagram reaches at the router, its buffer is already full up. In such a case, router does not discard the datagram directly. Before discarding, router checks the next level protocol number mentioned in its IP header. If the datagram belongs to TCP, then it tries to make room for the datagram in its buffer. It creates a room by eliminating one of the datagrams having lower priority. This is because it knows that TCP is a reliable protocol, and if it discards the datagram, then it will be sent again by the sender. The order in which the router eliminates datagram from its buffer is ICMP greater than IGMP greater than user datagram protocol and TCP transmission control protocol, ICMP internet control management protocol. So if the protocol number would have been inside the datagram, then router could not look into it. This is because router has only 3 layers: physical layer, data link layer and network layer. That is why protocol number is a part of the IP header. Header checksum. Header checksum is a 16-bit field. It contains the checksum value of the entire header. The checksum value is used for error checking of the header. At each hop, the header checksum is compared with the value contained in the field. If the header checksum is found to be mismatched, then the datagram is discarded. The router updates the checksum field whenever it modifies the datagram header. Source IP address is a 32-bit field. It contains the logical address of the sender datagram. Destination IP address is a 32-bit field. It contains the logical address of the receiver of datagram. Options is a field whose size varies from 0 bytes to 40 bytes. This field is used for several purposes such as record route, source routing and padding. So 14 total you have in the IP header. So we'll see some concepts, that is record route. A record route option is used to record the IP addresses of the routers through which the datagram passes on its way. When record route option is set in the options field, IP address of the router gets recorded in the options field. The maximum number of IPv4 router addresses that can be recorded in a record route option field of an IPv4 header is 9. Source routing. A source routing option is used to specify the route that the datagram must take to reach the destination. This option is generally used to check whether a certain path is working or not. Source routing may be loose or stricter. Padding. Addition of dummy data to fill up unused space in the transition unit and make it conform to the standardized size is called padding. Option field is used for padding.